So beyond the actual more translational side of regenerative medicine, we've got other areas we're investigating. This material is very interesting. There's lots of different facets to its use. So we're exploring, first of all, the effects of the clay particles on cells themselves. There's a lot in the literature about the direct osteogenic activity of these nanoclay particles. Often it's attributed to the degradation products. So it's basically a magnesium, lithium, silicate. And so they're the three degradation products. Each of those have a role in or interact with various osteogenic pathways. So we're very interested in that question. It's something that we don't see so much in vivo, but in vitro, certainly we see upregulation of various osteogenic pathways when you apply clays to cells. We're also interested very much in self-assembly processes and how we can use and control the gel self-assembly process to distribute and pattern gradients of proteins within the gel. So that was another talk by one of my group here at TERMIS, was on the ability to pattern proteins within these gel structures. That's Roxana Ramnarine-Sanchez. Done a lot of work on biodistribution in the body. So Yang Hee Kim, another one member of my group, was also presenting at TERMIS on the fate of clay particles following implantation. And we essentially showed that over 8 weeks, you do see degradation of the clay gels at the site. You see invasion of macrophages. You see transport of the clay away from the site. And then within the body, you don't see it accumulate in the lung or other kind of systemic tissues. You don't really see it in the blood, in fact. You see early presence of it in the liver, and then it's mainly in the kidney and bladder at later stages. So that suggests an excretion pathway for the clay particle following implantation. And then the other key focus we're working on a lot is the use of nanoclays in relation to macrophages and the ability to use clay properties and delivery of drugs to modulate macrophage responses to an implanted biomaterial, again, to accelerate bone and other tissue regeneration responses.